Okay, so here we go. I want to go over this free body diagram thing again for just this particular one. Let's take a look at what forces act on B. Well, what pulls B down? That should be simple. It's going to be your force of gravity. And you may say, let's do all of our forces of gravity at once. I agree. Right here, action on A is another force of gravity. Now, let us look what pulls B up, though. B could possibly just hang out there. It doesn't have to always go down. Well, what could pull B up? It could be your tension. And remember, guys, Newton's third law says for every action there's an equal but opposite reaction. I'm going to put it right here so I can put all mine coming from another point. There should be another tension. And let's label these tensions to be a little more specific. This is going to be tension B. So let's label the tensions that act on our A, though. Here and here, put it off to the side, we should have our tension A's. Okay, now we need to go over here to A. We're going to have some other interesting things acting on A real quick, and then we'll be done. I'm trying to pick out some colors I haven't used yet. What acts up? Oh no. Acting up, you should have a normal force. And then keeping this object from, and this is only on certain situations, keeping this object from moving could possibly be a force of friction. Now, hopefully you figured this out from this class, guys. Right now, in kinematics, you really have to constantly do your two F nets. So your F net, the first one is MA. And we can customize that right away. We're going to have two masses here, and since they are tethered, since they are connected, your F net is going to equal the sum of your two masses, MA plus MB, close parenthesis, multiplied by A. And this is the acceleration of the system. And these are the two masses of our system, and they are stuck together. We can combine them because they are not independent. They move. The movement of one depends on the other. Okay, let's make our other F net formula real quick, guys. Our F nets, in this case, I like to keep it very simple. If you really wanted to be professional about it, you'd add up. You see, I'm just going to do it's a summation of all your forces. But if you wanted to be professional, you would say your F net is, you'd have to do the F net X is the sum of all your forces in the X. You'd have to do your F net Y is the sum of all your forces in the Y. And that's how like a true professional would approach this problem. And then you would take your F net Y and your F net Y and your F net X, and you'd add them together head to tail. But because this is actually pretty straightforward, we don't really have to consider this. We can just simply cancel things out. Now, the one thing to realize is let us get rid of our, well, let's add them all up. Let's do the summation. Let's be very, very basic about it. Let's go F net equals FG plus F. Oh, sorry. This is driving me crazy today. Plus TB minus TB minus TA plus TA plus, and I'm going to be more specific, FGB plus FN. Now, with your FN, we can say this FNB, and then plus FF. So what you first do is you find out which ones cancel out. Now, the negatives, guys, and I may want to start to move away from this, the negatives, they don't really matter so much, but it's nice to know that since these are in opposite directions, so these are opposite directions, this guy cancels out with that guy, this guy can't, oh, well, come on, this guy cancels out with this guy, And then you should also be aware that these two guys are going to cancel out. So if we come up here, we'll see that these two guys cancel out. These two guys cancel out. And these two guys cancel out. So that leaves us with simply an fnet equals FGB minus, we'll say plus FN or FF. Now the one thing to realize, guys, is that FG, this FGB right here, now it wants this whole system to move like this. It wants it to pull this guy this way and pull this thing down. So this is where the FGB wants you to go. Is that the way that the FF wants you to go? No, the FF wants to go this way. Do you see? Because our FF is pointing this way. So it wants to pull B up and it wants to pull A to the right. These have to be made in opposite directions. So when you solve for your values, let's just say that this is negative 9.81 newtons and this is 3.6 newtons. We'll say 3.3 newtons. I don't know why it's going crazy all of a sudden. But what I'm trying to stress is this, is that when you put these into your formula, they have to be opposite values. And the opposite values show you that they're going in opposite directions. And then you can solve for your fnet. You really have to wait till the last possible moment and then look at your signs. At the last moment, right before you put it in your calculator, look at your signs. This sign tells me this goes one way, and this tells me that one goes the other way. Okay? All right, hope this helped.